let's say that you have a linked list. It might look like head pointing to a node, pointing to another node, pointing to null, which would mean that this linked list has two items. It has a length of 2, and we might give these items an index. Like this might be index 0, this might be index 1, if we're a 0-indexed society. Remember, let's recall that each node stores 2 variables. A node will store a variable called next of type node, and might store a value of, I don't know, some value. And for example, a head node has no value, and its next would be this, would point to this. This node right here might have some value, and its next would point to this. This node might have some value, but its next would point to null to indicate that it's the last item in this linked list. Now, how would we iterate across multiple items? Well, we can do this with a for loop. So let's write a function, get item, get at index. Now, all we have access to is the head. Now, let's just start with that. Current is equal to head. Now, for example, if we wanted to go from head to index 0, we would have to jump once. So we would have to take the next once. If we wanted to get to index 1, we would have to do head.next. So we have to do next twice. Now, we could do this with a for loop. So this is a for loop that has a variable I that increments by 1, and we would want to set the condition to I less than or equal to index. So, for example, if we have index 0, we would run the item, we'd run this loop once, because it satisfies this condition once. And if it's 1, then we would satisfy this condition twice. So we'd run it twice. Now, we could move by saying current is equal to current.next. And then at the very end of it, we'd be where we wanted to, and then we return current. All right. Now, what if we wanted to delete? Well, to delete something, we simply have to dereference it. And in this case, it would mean that no node should be pointing to this. Like, maybe we bypass this straight to here, and then this node would be effectively deleted. Now, you can see there's a problem, because if we move to this node, we can't access its previous. But what if, while we were iterating to it, we just stored the previous node that we iterated to in some kind of variable? Let's try that. So func del item at index. We might say previous is equal to null, because there's no previous to the head. And then we would say current is equal to head, just like before. Now, same thing. So every time we move the current node, we should store the previous. Now, we can do this like this. Previous is equal to current, and current is equal to head. No, current is equal to current.next. Now you may see a problem here, which is, what if we give an index that's like outside, right? So for example, if for some reason we're pointing to this, we accidentally like say delete item at index 2, we iterate all the way here, and there's nothing. We could set a guard for that, which would be if current is equal to null, then return. So we just quit the function, and let's keep going. So say that we have traversed to where we want to be. So this is current, this is previous. Or this is current, this is previous. Now how do we delete it again? We set previous.next, which is this line, to be current.next. And then maybe we're done. Now you may notice that, what if we like put an index that's like less than 0? Well, I assume that you're not going to do that, but if you think someone's going to be silly enough to put that in your function, maybe you just put like a little line that says if idx is less than 0, return. Alright, and we're set.